Hello friends, welcome to my channel. Let's have a look at problem 2345 again, finding the number of visible mountains. So in this video, we are going to share a solution based on filtering plus stack. So in the previous video, actually we shared a solution format by translating the current problem into the general line of idea for addressing the problem of interval merge type. So here I would say in this problem, actually the stack container is not absolutely necessary. But if the problem requires us to return the mountains that can be seen, so this method or this format of solution will be convenient. So this problem asks us to return the number of visible mountains. And for example, in example 1, so 3 mountains are given, and 2 of them can be seen. And in example 2, so we have 2 mountains, and they are actually identical, so we can see none of them. So the main constraint on this problem is that the number of mountains can be up to 10 to the power 5, and the latter is a decent large number. So with that said, let's look at the method here. So as we mentioned, the method is filter plus stack. So the idea is the following. First, we're going to do some filtering based on example 2. The reason is that if there are identical mountains, none of them can be seen. For example, we have 2 or more mountains like 1, 3, 1, 3, and 1, 3, and so on. Secondly, we do some sorting. So after we transforming the mountains into intervals, for example, with such a form, start and end, then we sort according to S increasingly and E decreasingly. So actually the latter extra sorting will enable us not using stack pop operations for this situation of intervals with the same start. For example, the intervals are -2, 6, -2, 10, -2, 8, and because we can only see one mountain in this situation, and we remain only the largest interval, so also the first after sorting, that is -2 and 10. So with that said, let's do a little bit of math. So just a extra. So given the peak of x0, y0, so the 2 sides of the mountain have slope. So have slopes c equals +1 and -c equals -1. Then the area covered by the mountain is given by the expression below, that is y minus y0 greater or equal to x minus x0. So in general, if the slope is c, so we should have y minus y0. So here no absolute value in this case, if we consider cone below. So greater than or equal to a absolute value of the c times the absolute value of x minus x0. So actually you can try to write the cone bounded or unbounded below or above, something like this, the corresponding equations. So in this video, based on the above analysis, the procedure will be the following. So first, we map the peaks to the corresponding intervals. And second, we use a stack to keep the mountains that can be seen. So actually, there are a number of Leetcode problems that can be transformed to interval merge type. So we can use the interval generation solution, or we can use monotonic stack or just stack for this kind of problems. So here are some examples that are good to keep in mind when we write the code, so that we can check if the code logic is good. So let's look at the code now. So first, based on our analysis, we'll do some filtering for the interval. So for this, I'm going to initialize a dictionary, and then we transform the peaks into intervals, and then count the frequency of the corresponding intervals. So for x, y in peaks, So the corresponding interval is actually, so here I'm going to use a tuple because tuple is immutable. So we want to use this interval as a key in the aux dictionary. That is x minus y, x plus y. And then we're going to set the frequency of this interval by incrementing its previous frequency by 1. So that is, first we are going to check if it exists, right? Get interval. If not exists, so we're going to use 0 frequency. Then we increment by 1. And for our purpose, we want to filter out the mountains that are identical, because none of them can be same. So aux equals, so I'm going to use a set comprehension. So atom, for atom in aux, if the corresponding count, that is atom. So let me do something. Yeah, so it's okay. So atom is greater than 1. So here we want to filter out those are greater than 1. So we'll see if its count is 1. So this aux are the mountains we're going to count. So next we're going to do a sort, right? So sorting. So sorting is actually, so let's see, call it intervals now. So I'm going to sort it, this aux. So the key will be a lambda function, and we sort corresponding to the first component increasingly, and for the second component decreasingly. So for the purpose of solving the problem, it's actually not necessary to do the secondary sorting, but if we do this, it brings some convenience and shorten the code length. So with that said, we finished the filtering and sorting. So next, basically the counting. So here we can use a stack, but it's not absolutely necessary. But for the video here, let's use a stack so that we can know which mountains can be seen. So first, I'm going to write a for loop in intervals. So notice that the intervals at the current stage are already sorted. So, and then we're going to consider when shall we put the interval in the stack. In other words, if the current interval we are examining can be seen or not. So first case, if not stack, then we should add this current interval into the stack. In other case, if the stack is not empty, in other words, there is previous mountain, so we want to compare that mountain with the current mountain. So we already know the current start is no less than the previous start. Then we just need to check if the end, current end, is greater than the stack top end or not. If this is the case, we're going to add the current interval into stack. Otherwise, if b is less or equal than this expression, it means that the current mountain is shaded in by the previous mountain in the stack, so we do not need to add it to the stack. So we're going to add this interval. So that's all we want to do. Actually, then finally we're going to return the length of the stack. So that's it for this solution. So here in this for loop for counting, we didn't use stack pop operation at all. The reason actually is due to the secondary key sorting here. So with that said, let's do a special case check. So list has no attribute add. So let's see. Append. Yeah, it passes one special case. Now let's look at the generic cases. Yeah, it passes the generic case. So I guess for this problem, and that's a solution format, you are encouraged to try other solution formats. For example, how to do the counting in step 3 if we do not do a secondary sorting key in this interval sort. So that's actually also a good practice. So with that said, I guess that's about it. Thank you very much.